So you can put that in the Word document. I'm talking about those calculations up there.
Oh, yeah.
See, because that's what part 5 is about, right? So now we've calculated numerically these difference quotients, right? We need a table of values. This is the other way to calculate limits, right? By just plugging in numbers close to the limit point. You know? So we've actually calculated these limits by plugging in numbers close to 0, right? So look here. Let's think about it now, right? Does it make sense? What we found numerically? Part A. What were the values in the table? You had like 0.166 stuff, right? What is 1/6 as a decimal? Do you know?
1/8.
No, 1/6 is a decimal number. No. Let's see here. I'll do it. So this is 0.16666666666. Okay, anyway. Repeats forever and ever. My point to you is the thing we just calculated in part A, look at your table. They're all increasingly closer to that. Except that 0 where it's undefined, right? So does that make sense? I think it does. Our limit calculation agrees with our numerics. So, and for part B, again, I will prove that in tomorrow's video that you'll watch. But f prime of 0, right? Cosine of 0, if you believe me, and that's 1, right? And that's what you saw for the difference quotient for the sine. You had values increasingly closer to 1, right? 0.999, you know? So that also is consistent with the numerics that you did. And part C, right? It is also evident that the limit doesn't exist, right? Because you can see that the values are negative on one side and positive on the other side, and there's a jump, right? So it can't match at 0, right? That limit doesn't exist. You can see that clearly in that table of values. So why don't we always just calculate limits by plugging in numbers close to the point? I mean, you could, right? But it's a pain. So we prefer to develop algebraic methods to cancel out things. And also because the truth of the matter is one of our goals in calculus is to get you guys much stronger in algebra. All right, because if you're going on to calculus 2, are you going on to calculus 2? Don't think so. Are you?
Yeah.
Yeah. So in calculus 2, right, so calculus 2, like all this algebra stuff we're doing, it stays with us and it gets compounded. So like one of the things you got to do as you're taking calculus is like refine your algebra skill, like make it perfect. Find all your demons and kill them, so to speak. But anyway, so that's, what was that, 5? So you take a picture and then put it into the, you don't have to if you don't want to. Like, I don't care. Do we understand each other? That's fine. That's fine. I'm sorry.
I'm taking notes of it.
You take notes of it. That is good. Yeah, I think that I should change the lab so you guys don't have to take a picture of the board. That's obnoxious. Like everything for the lab should be contained on the computer there, you know? You shouldn't have to use your phone. That's dumb. All right. Next. So I would like you to type out a couple sentences that say what I just said as an answer to 5, yeah? In the meanwhile, try going to Wolfram Alpha .com. See if it works.
Just answer it to 5.
The answer to 5 is yes. We plugged in the values and they match the numerical method, the numerical data we found in 4. You can just put that there. That will suffice. I'm too tired to do more. Sorry. Did you understand what I think you were nodding your head, so I think you guys understood what I was saying on the board, right?
Yeah.
Okay. So did you guys get Wolfram Alpha open? All right. So Wolfram Alpha, what won't it do? I don't know. It'll do most anything. But one of the things it'll do is differentiate. So you can check derivatives using Wolfram Alpha. Let's try it out. Say differentiate the square root of x plus 8 at a equals to, let's try it out. So let's see here. So notation for differentiation is like d dx. I know we haven't talked about that yet, but d dx is differentiation. And then we got square root of x plus 8. So we could put x plus 8 to the 0.5 power, right? But what do we want x to be equal to? With x equal to what? For part A, 1, right? So if you could do like d dx of that with x equal to 1, the result is 1/6. So, as you're working on your homework, is it not liking you again?
Yeah, it doesn't work. I don't know why.
Huh.
Can't even type in.
Wonder what's going on. I always wonder if it's just that computer. Like if you moved it.
Chrome.
Oh yeah, are you using Chrome? It will work in other browsers, but I'm used to Chrome. So if you like Google Wolfram Alpha, you'll. I'll write it over there. It's easier. There are many ways, but here's one way. I think you could also do this. I think that would be an alternative notation for it. Wolfram Alpha is very open-minded, though. You could use words. You could be like, you could use the word differentiate. It would do it. So like this is the ddx notation for derivative. This is the so-called prime notation. So ddx of f of x is f prime of x. These are notations we'll be using. I guess I should.
And that's just an example. The 8 and the 0.5.
The what? Oh yeah, that's part A.
Before.
That's part A. That's the A function, right?
It doesn't say it on here, that's all that.
Oh, I didn't say what to differentiate?
Mm-hmm. You just said found at 6.
Oh, did I forget? Did I mess up the numbering?
Take a screenshot of
Yeah.
the graph.
Oh, yeah, that's unfortunate. That was supposed to be found in 5. That 6 is supposed to be 5. That's a typo. I have eliminated something in this lab to make it shorter. Thank you. I mean, you're welcome. So unfortunately, that's supposed to be 5. So yes, the derivative. My point is we can use Wolfram alpha to symbolically calculate the derivative. And you can try differentiating sine x, see what you get. ddx of sine x in Wolfram alpha, what does it say? So what's the first problem in your homework? When's that due? When did I make your homework due? Next Tuesday, right? So beware, there's a lot of problems in there, right? I want to show you something. So here's mission 1, right? What was problem 1? Factor x to the 5th minus 16x completely over r, right? You can check your work with Wolfram alpha. See? Try it. Type in Wolfram alpha, factor x to the 5th minus 16x. See what happens. Look at that. See that? Not only did it solve the problem as I've asked you to solve it over the reals, it even told you if you were using complexes, factors like that. So I would encourage you, if you're uncertain about a homework problem, you might be able to check your answer with Wolfram alpha pretty easily. You know, it's a good way to double check yourself. And of course, you can email me if you're ever uncertain about a problem, you know. Do you guys have any other questions about the homework while I have it open? See this problem 12? Does this look familiar? See this problem 12 right here? C be a constant, define f of x for x less than 4, greater than 4. This is that problem, essentially the same problem we worked at the start of class last time. That's the paste the left and the right together to find the C kind of problem, right? So that problem 12 is a lot like what we did in class. Anyway, you can definitely double check all these limits with Wolfram Alpha. It's not hard. You can just, I mean, try it out. Limit of x minus 1 divided by x squared minus 1 as x approaches 1 from the right.
Are we supposed to do
See?
every problem?
So Wolfram Alpha is it's some kind of an artificial intelligence that takes words, English sentences, and converts it into Mathematica. It's incredibly useful. Now, it doesn't always. I know how to verbalize mathematics because I teach math, right? So when I say a mathematical sentence, it is what it is. When you try to use Wolfram Alpha, you're going to have to tweak. You're going to have to tinker with your wording more because you're not used to how to verbalize math. But you can check all kinds of stuff with Wolfram Alpha if you want. One question?
Yeah, where are we supposed to do every problem to Tuesday?
Yes, that is true. So I would suggest starting soon. Many of these are easy. A lot of those are like, 3 minutes. But yeah, there's a lot. There is a lot. That is true. Just why I warned you guys to start on it. All right, so where are we? So you got your Wolfram Alpha. What's next here? 7. I said make tangent lines at a comma f of a. All right, so I hope this link works for you guys. I don't know why the other one didn't. Control click. It does that for me. I don't know what it does for you. So I'm doing number 7, which is the final part of the lab. We'll be done. Now, I'll tell you what, I'm just going to cancel part 7 from the lab this week. I don't think I'm going to make it. I'm sorry, guys. We're going to stop here. You can skip 7. Basically, all 7 was to graph the tangent line for arbitrary a. So like this example I have here has it done for y equals, see this y equals sine of pi x squared over 4. You can adjust the h and see that blue line? That's the secant line. See how that goes? As h varies, the secant line, but as h goes to 0, the secant line becomes that dotted green line, which of course is the tangent line. But I've also geared this thing up so that you can move the point of tangency around. See? So I think that's kind of neat. I don't know what b is. I shouldn't probably mess with that. Oops. Well, anyway. So, and then of course you can, well, let me just, oh, I shouldn't have done that. So anyway, you can see, you can even animate with this thing, right? If you hit play on the slider, it'll go through and show you the different tangent lines. So, I'm sorry, guys. I can't do this with you. If to do this, I'd have to be right over your shoulder and talking like close to you, and I don't think it's right to do that right now because I just don't know. So. Anyway, so that's it. So just, make sure you've included your answers for 1 through 6 and post it in the, you see where you submit it in the course content, right where you found it? You should be able to submit it there. Down in the, and yeah, I think if you click on that, click on the lab one.
Yes.
No, the lab one.
Oh,
that,
yeah.
and then you can put the file there.
Okay. And we do 7 alone.
Hmm?
We're supposed to do 7 also.
No, you can skip 7 because I can't instruct.
Oh,
So
we can send it in right now.
no, I can't help you with 7. If you want to do 7, that's great, but you don't have to because I can't help. But if you've done all through 6, you'll get. I mean, I'm not very critical with labs. If you come and you make a good faith effort, I'll give you 20. Like, I just want you to come and so we can talk together about this.
So
And
we can send it in right now.
what's that? Yeah, you can just submit it. It's fine.
Yeah.
Now, but the larger point here is I want to make you aware of like Desmos and the Wolfram Alpha because these are very useful as you're working on homework to like double check your work and just to see things. And then of course there's also Audric, right? So our beloved calculus tutor.